I have plugged in the M5 stack StickC using USB-C. Now our firmware is successfully flashed to the M5 stack StickC+2. Now the agent is started. As you can see, now the session is established. Now we can see what this topic is publishing with ROS2 topic echo and topic name. And now you can see the data which is coming from the ESP32 board. In our case, M5 stack StickC+2. Hey everyone, welcome back to the channel. Today I will show you how to use MicroROS with ESP32 based M5 stack StickC+2. First, let's go to the MicroROS GitHub repository. Here you have all the projects for MicroROS. We'll go to repositories. In repositories, we will find MicroROS PlatformIO. We will use MicroROS PlatformIO project to flash the ESP32. Here you can see the supported boards. It supports ESP32 dev, which platform, framework, which transports, what is the default meta file. We will be using ESP32. In our case, we will use PlatformIO to flash the firmware to the ESP32 board. You can explore this page. We will be using Humble. I have installed ROS2 Humble and we will be using the serial mode. There are different modes, Wi-Fi, serial. In our case, we will use the serial mode in PlatformIO MicroROS. Now let's start Visual Studio Code. Go to Extensions, search for PlatformIO extension. If you have not already installed PlatformIO, install it. Select the PlatformIO ID from the left sidebar, then click Install. It will take some time to install. Once PlatformIO ID is installed, just reload Visual Studio Code. Now PlatformIO ID is installed. You can click on the PlatformIO icon on the left side. Then in the project task on the left side panel, you can select Create New Project. Once you click on Create New Project, PlatformIO homepage opens. Then you select New Project. In the Project Wizard window, you can give the name. In my case, I will use M5 stack M5 StickC. When you are using ESP32 dev board, you can select ESP32. There are many ESP32 boards supported by PlatformIO. Depending on your board, you can select which board you want. You can either select ESP32 dev kit if you have a dev kit. In my case, I have M5 stack StickC plus 2 and select M5 stack StickC. The framework will be Arduino. Click on Finish. This setup will take some time. Now the setup is ready. You can click on Yes, I trust the authors. In the Explorer, you can see the files. This is the PlatformIO IDE specific file, platformio.ini file, which is created automatically for M5 stack StickC. We will change the platformio.ini. Go to StickC plus 2 documentation page. You can see it supports PlatformIO and other IDEs like Arduino IDE. Just scroll down. At the end of the page, you will see the platformio.ini section. This we need to copy to our ini file. Let us copy this ini content to our ini file. Once you copy, you can save the file and PlatformIO will start configuring the project. This process will take some time. Now the configuration is done. Let's go to source main.cpp. This is the basic Arduino style code which has setup, loop, and main function. Let us try to build it. Click on this tick mark. This is building the project. It is trying to build the firmware. The firmware is built successfully. Now let us try to change the file. We'll go to MicroROS PlatformIO in the examples folder. In micro-ROS publisher inside SRC, you have an example main.cpp. We'll copy this code. This has a micro-ROS publisher node. This code creates a node publisher node and publisher topic. We will copy this to PlatformIO. Back to Visual Studio Code, we will replace the main.cpp with the copied example code, which is a micro-ROS publisher node. This code will just publish numbers in a loop. Now we have to update the platform io.ini for MicroROS project. Let's go to the PlatformIO GitHub project. In that example, we have platformio.ini. Let us copy the board MicroROS transport property. In our case, we are using serial, putting board MicroROS transport equal to serial. Next, we need to copy the libraries, the MicroROS PlatformIO libraries. This is the path. We'll copy it to PlatformIO.ini, and once you save it, starts configuring. Also, we need to tell which ROS we are using. In our case, we are using MicroROS distro as Humble. We have to tell that we are using board MicroROS distro equal to Humble. We have to update this property in PlatformIO.ini. Let me check if anything else has to be updated. These are the basic 3 things which are required. Others we can explore later. Let me add board MicroROS distro equal to Humble and save it. It will take some time to configure the project. Now it is configured. The whole project is configured. Now we'll compile this main.cpp. Click on build. It's building again. It will take some time. Now the firmware is built successfully. We will try to flash it to the M5 StickC. Let me connect the M5 StickC Plus to the computer. Now I have plugged in the M5 StickC using USB-C. I am using a virtual box. Let me make sure that I select the proper USB port. Let me confirm if it is selected. Yes, now it is selected. USB port is selected. We will try to flash it to the M5 StickC. Press the power button. By pressing the power button, now it's in download mode. Now you can see it's flashing. It has successfully flashed. Now our firmware is successfully flashed to the M5 StickC plus 2. Now next thing is we have to do setup for the host. For host, you can go to micro-ROS page, click on tutorials. In tutorials, click on first micro-ROS applications on RTOS. Click free RTOS. We will do the first installing ROS2 and micro-ROS build system. In my case, ROS2 Humble is already installed on Ubuntu. We will do these steps for micro-ROS build system. Let's go to terminal. Here you can see I have already installed Humble. Now source the setup.bash. Then our next step is to create a workspace and download the MicroROS tools. The MicroROS tools are downloaded. Next step is to update dependencies using ROSDEP. It will update all the dependencies for our ROS. Let's do ROSDEP init and ROSDEP update. Let's do ROSDEP install again. This time it should work. This will also take some time. Now it's installed successfully. Now let's install pip. In my case, it is already installed, but we'll just confirm. Yes, it's installed. Next, we'll do MicroROS tools and source build. It's done. Now the MicroROS tools is installed and built. Now let's try to go to next step. Next step is creating a new firmware is already done using PlatformIO. We'll skip this step and we'll go to create the MicroROS agent, which is on host. We will download the MicroROS agent packages. Once they are downloaded, we will build the MicroROS agent. Now the MicroROS agent is built. Let's source the setup.bash. Now let's test that the MicroROS is working. Let us start the MicroROS agent. In our case, we are using serial communication. We'll try with the serial. This is the command to start the agent. In our case, the device is /dev/ttya-cm0. Now the agent is started. Let me press the power button on the device. As you can see, now the session is established. Now open another terminal. Let us source humble setup.bash and MicroROS workspace setup.bash. Now we can see the nodes and topics. Let me check the topic with ROS2 topic list. You can see now a new topic is created. MicroROS _ PlatformIO _ node _ publisher. Now we can see what this topic is publishing with ROS2 topic echo and topic name. And now you can see the data which is coming from the ESP32 board. In our case, M5 stack StickC+2. That's it for today's MicroROS video. If you found this helpful, smash that like button and subscribe for more IoT and robotics development content. I'll have more videos on MicroROS coming soon. Thanks for watching, and I'll see you in the next one.